Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Okay, it says, in the diagram, MN is congruent, so MN is congruent to LQ, and LQ is congruent to PN. Okay. Describe and correct the error in the reasoning. Okay, so we're finding something is wrong with this, and we need to figure out what's wrong. So because MN is congruent to LQ, then MN is congruent... Oh, wait, I missed something. Because MN is congruent to LQ, and LQ is congruent to PM, then MN is congruent to PN by the reflexive property of segment congruence. Is that the reflexive property? The reflexive property is when A equals A. This is way more than the reflexive property. Which property is this? It's not the reflexive, it's the transitive property of segment congruence, but I don't care if you just write transitive property. So yeah, because MN is the same as LQ, and LQ is the same as PN, you can see right here in the diagram, MN and PN have the same tick marks on them. So yeah, MN is congruent to PN, and we call that the transitive property of congruence. Woohoo! Okay, all right, let's move on to what we have for today. Today we move on to section 2.6. Today is the first part of two parts of section 2.6, and it is all about proving geometric relationships. So in 2.5 we talked about proving things about segments and angles. Now we're focusing on geometric relationships as a whole. So any type of relationship between objects in geometry we could look at in this section. The learning target is that you know what flowchart proofs are, and the success criteria is that you can write flowchart proofs. So we're going to continue writing proofs in this video, and we're going to continue writing proofs in the next video as well. So first, what is a flowchart proof? Well, a flowchart proof is a type of proof that uses boxes and arrows to show the flow of a logical argument. So maybe you didn't like the step 1, step 2, step 3. Maybe that didn't quite make sense for you. Maybe it did. But here is an alternative type of proof where from this tells me this, and this tells me this. So the arrows kind of show you, first I do this, second I do this, but it kind of shows the flow of things. And you can see in the blue, next to the boxes, they give the reason. So it's still like statement and reason, because the reasons are what make a proof a proof. You're always going to have reasons. So the reasons are outside of the boxes, the statements are inside of the boxes, and then we use the arrow to show the flow of the proof. So that's what a flowchart proof is and what it looks like. Now, we are going to talk about an important theorem, and then we're going to prove it using flowchart proofs. So, this theorem is the right angles congruence theorem, and it simply states all right angles are congruent. Now, you might think that's obvious, but the reason that it is a theorem, remember, theorems need to be proven. Postulates, oh, we accept that as fact, but theorems are things that can be and need to be proven. So we can prove that all right angles are congruent, and we're going to do that now. So, example 1, we are proving the right angles congruence theorem, and the instructions tell us to use the given flowchart proof to write a 2-column proof of the right angles congruence theorem. So we are given angle 1 and angle 2 are right angles, and we want to prove that angle 1 and angle 2 are congruent. Now this, even though we're looking at two specific angles here, this will show that all right angles are congruent because I just drew a right angle, but we're calling it number 1, and another right angle, but we're calling it angle number 2. If these two right angles are congruent, it means that all right angles, even if I added an angle number 3 or an angle number 4, it means that all of them are congruent because two random angles that I picked happen to be congruent. Okay, so we are given that angle 1 and angle 2 are right angles. That is the given. So they already wrote this proof for us. What we're going to do is we're going to understand the proof, and we're going to use it to write a two-column proof. So we're going to make statements, reasons, but we're going to use their flowchart proof to make our two-column proof. So, first, they say angle 1 and angle 2 are right angles. Then, they say that the measure of angle 1 is 90 degrees and the measure of angle 2 is 90 degrees, because that is the definition of a right angle. So, going from this step to this step, going from, and you could think of this as step 1 and step 2, and that's what we're going to do right down here. We're going to write step 1 and step 2 in our flowchart proof. But why? So angle 1 and angle 2 are right angles. Then I jump to them being 90 degrees. How do I know that angle 1 and angle 2 are 90 degrees? Well, they are right angles. And what does it mean to be a right angle? It means that you have a measure of 90 degrees. So cool, that makes sense. That makes wonderful sense. I get that step. Oops. I get that step, that arrow, I understand. Okay, now let's see this step. So from here, from the measures of these angles are 90 degrees, we get that the measure of angle 1 equals the measure of angle 2. By the transitive property. Oh, okay, yeah, that makes sense, because they're both 90 degrees. So measure of angle 1 is 90 degrees, measure of angle 2 is 90 degrees. We're just cutting out the middleman. And now measure of angle 1 equals the measure of angle 2 by the transitive property. Okay, so because they're both 90 degrees, they're equal to each other. Great, I understand that arrow. This is like step number 3. And now, how do they get, so from here, we know that the measure of angle 1 is equal to the measure of angle 2. Now, how do we get to them being congruent? Ah, the definition of congruent angles. If two angles have the same measure, if their measures are equal, then they are congruent. That's what it means for two angles to be congruent. That is the definition of congruent angles. So now, I understand this arrow too. And that's step 4, and that's what we wanted to prove, so that is the end of our proof. Okay, so now all we need to do, now that we understand the proof, we're just going to write it in a two-column format. So step number 1 was angle 1 and angle 2 are right angles, given. Step number 2 was, I know they're right angles. If they are right angles, that means that they must be 90 degrees. Why? Because that's what it means to be a right angle. That's the definition of a right angle. Okay, then from there, because measure of angle 1 is 90 degrees, and the measure of angle 2 is 90 degrees, we know that the measure of angle 1 must be the measure of angle 2 by the transitive property. And now, because their measures are the same, they are congruent. That's what it means to be congruent. For if two angles are congruent, it means that they have the same measure. So this is just the definition of congruent angles. I'm using a little bit of abbreviation, but hey, we have the symbols, let's use them. Okay, beautiful. We used the flowchart. We have written our 2-column proof. We started with what we were given, and we ended with what we needed to prove. So, we're done. We did the problem. Beautiful! We can check and make sure that we were right. Yes, yes we are. Yay! Okay, next, what we're going to look at is the congruent supplements theorem and the congruent complements theorem. Now, we're going to prove one of these in our next example, but in order to prove a theorem, you need to understand what the theorem says, and you need to believe that the theorem is true for yourself. This is like the steps to create a proof that I didn't understand when I first started proofs. When I first started proofs, I was like, we start here, we end here, what? Why? And then we pick some theorems to shove in the statement boxes, and no. That's not what a proof is. To do a proof, you have a theorem, the if is what you're given, and the then is what you're trying to prove. And before you even start this proof, you want to think in your head, do I believe this theorem? If this happens, am I convinced that this will happen? Am I convinced? If you're not convinced, how are you going to write a proof about it? You need to believe, and you need to have reason that you believe this theorem is true before you even start trying to prove it. So, let's look at the congruent supplements theorem. It says, if two angles are supplementary to the same angle, then they are congruent. And we see an example here. If angle 1 and angle 2 are supplementary, and angle 3 and angle 2 are supplementary, then angle 1 is congruent to angle 3. Do I believe that? If angle 1 and angle 2 make 90 degrees, and angle 2 and angle 3 are 90 degree, not 90, 180, supplementary means 180. So if both of these angles make 180 degrees with the same angle, these angles have to be the same. Do I believe that? Pause the video and decide for yourself, do you believe that? And then unpause it and you can hear my reasoning. Personally, this seems a lot like the transitive property. 1 and 2 are supplementary, 3 and 2 are supplementary, so 1 is congruent to 3. This isn't exactly the transitive property, but it seems like it to me. If this thing is supplementary with this thing, and this thing is supplementary with this thing, angle number 2 hasn't changed. Angle number 2 is the same angle. So yeah, these have to be the same. Let's try some numbers and see if this makes more sense. Let's say angle 2 is 150 degrees. In order for angle 1 to be supplementary with angle number 2, it would need to be 30 degrees, so that together they add up to 180. Okay. Now, what would angle 3 need to be in order to be supplementary with angle number 2? Well, angle 3 and angle 2 need to add up to 180 degrees, so that would mean that angle 3 needs to be 30 degrees. Oh! Angle 1 and angle 2 are both 30 degrees. Yeah. Is that going to happen every time? You could pause the video and try this exact same process with another. Maybe this is 140 degrees. Will angle 1 and angle 3 still be the same? You can try it for yourself if you want to pause the video. But yes, this will always happen. Because both of these things, both angle number 1 and angle number 3, need to add up to be 180 with angle 2, and angle 2 is not changing. So yes, I am convinced that then angle 1 and angle 3 are congruent. because they have the same measure, and that's what it means to be for angles to be congruent, is that they have the same measure. Okay. The congruent complements theorem says the same thing. Surprise. It says the same thing, but now we're talking about complementary angles instead of supplementary angles. So, if two angles are complementary to the same angle, then they are congruent. So if angle 4 and angle 5 are complementary, and angle 6 and angle 5 are complementary, then angle 4 is congruent to angle 6. And this is because, notice, 4 and 5, 6 and 5, then 4 and 6. Again, it seems like the transitive property. It's not quite the transitive property, but it's similar. So yes, the reasoning here is the same as the reasoning up here, so for the sake of time I won't go into it. But if you want to try, make angle 5 something. Make it 45 degrees. Make it 50 degrees. Make it something, and see if angle 4 and angle 6 would need to be the same in order for both of them to be complementary with angle number 5. You can try that for yourself, and you can see that yes, the congruent complements theorem is indeed true. So now, example number 2, proving a case of the congruent supplements theorem. So now we are told in our instructions that we are supposed to use the 2-column proof to write a flowchart proof that proves that two angles supplementary to the same angle are congruent. Okay, so now we're going to have boxes that we write stuff in, and it's gonna flow. And I know, so where they got the given from is, remember, in the theorem it says if two angles are supplementary to the same angle. This is what we're going to be given. The if is what is given to you, because this is what we're assuming. We are assuming this, so it's a given. Okay, and then the then is what you're trying to prove. Prove blank. Prove the then. If we assume this, can we say this? Okay. So that's exactly what we have. Given angle 1 and angle 2 are supplementary, angle 3 and angle 2 are supplementary, we want to prove that angle 1 is congruent to angle 3. So let's go through their proof and make sure that we understand it, that we understand the proof that they have done. So angle 1 and angle 2 are supplementary. Yeah, that's our given. Okay, so I understand that. That's what we're assuming. That's what we're given. The measure of angle 1 plus the measure of angle 2 is equal to 180. Oh, that's what it means to be supplementary. Measure of angle 3 and the measure of angle 2 is equal to 180. And yeah, that's what it means to be supplementary. Is if you tell me angle number 1 and angle number 2 are supplementary, you're telling me measure of angle 1 plus measure of angle 2 equals 180. Because that's what it means to be supplementary angles. And then yeah, that's the same thing with measure of angle 3 and angle 2 are supplementary. Okay, cool. So I understand step number 2. That makes sense, and it follows very nicely from the first statement to the second statement. Okay, now I have that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 2 by the transitive property of equality. Ah, that's because they're both equal to 180. So both of these things, and let's see here, I'll highlight it for you. Measure of angle 1 plus measure of angle 2 is equal to 180, and the measure of angle 3 plus the measure of angle 2 is also equal to 180. So because both of them are equal to 180, they have to be equal to each other. That is the transitive property of equality. So yes, I understand that step. If I'm going too fast and you need more time, please pause the video and make sure that you can put these check marks there too. That you understand each of these steps too. Okay. So from here, from this step, I understand why these are equal to each other because of the transitive property. Now from here, they get that the measure of angle 1 is equal to the measure of angle 3. So what happened to the measure of angle 2's here? Oh! Well, we can subtract them from both sides. If I take this, measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. If I subtract the measure of angle 2 from both sides of the equation, it gets rid of it over here and it gets rid of it over there. And now I just have measure of angle 1 equals the measure of angle 3. So this is the subtraction property of equality. That I can just get rid of these measures of angle 2 by subtracting them from both sides. Yeah, okay. 100%. That makes sense to me. Now, from here, from their measures being the same, the angles have the same measure. That means that they're congruent. Yeah. Congruent angles have the same measure. So, that's what it means to be a congruent angle. So yes, that step makes sense. And, look at that. We have proved what we wanted to prove. We wanted to prove that given any two angles that are supplementary to the same angle, those angles will be congruent. And we proved that. Beautiful. Okay, now all we have to do is, sorry, it's fine. We have to write a flowchart proof. That's what they wanted us to do. Use the two-column proof to write a flowchart proof. Okay, so we're going to start with what we're given. Angle 1 and angle 2 are supplementary. And angle 2 and angle 3 are supplementary. I'm just writing the first statement in my first box. Now from here, they said, that the measure of angle 1, oh wait, we need to write our reasons. Our reasons was that this was given. So right next to the box in my flowchart proof, I'm going to write the reason, and it was given. Next, I'm just going to take the second step, and I'm going to put it in the next box. So measure of angle 1 plus measure of angle 2 equals 180, and measure of angle 2, plus the measure of angle 3 equals 180. That's my second box, because it's my second step. And the reason is the definition. I'm going to abbreviate definition by saying definition of congruent angles. And I'm abbreviating congruent with the congruent symbol, and I'm abbreviating angles with the angle symbol. Okay. Perfect. So we finished step 1, we finished step 2. Now step 3, the third box, I have that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. That's my third box because it's my third step. And the reason for that was the transitive property of equality. Transitive property. Oh, you can't read the TY, but it's the transitive property. Okay. From there, we were able to say that, step 4, we were able to say that the measure of angle 1 is equal to the measure of angle 3. Why were we allowed to say that? Because we subtracted the measure of angle 2 from both sides, and that left us with measure of angle 1 equal to the measure of angle 3. And that was the subtraction the subtraction property. I know you can't see the rest of the word property, so I'm not even going to write it. Subtraction property. Okay, then, that was our step 4. From there, we know if they have the same measure, they are congruent. So because they have the same measure, the angles are congruent. Whoops. Okay, and our reason for that was the definition of congruent angles. Oh my. I just noticed that was the same reason we put down here. We were wrong. That was the definition of supplementary angles. If you caught that I made a mistake, good for you. And if not, don't worry about it. We understood the proof up here, so we were just writing the 2-column proof as a flowchart proof. So there you go. Which do you like better? Do you like flowchart proofs better, or do you like the 2-column proofs better? It doesn't matter which one you like better. As long as you can follow the logic and you can follow the reasoning of both types of proofs, that's what matters. So we can check and see if we were right. They split these, we had this in one box, they split it up into 2 boxes. That's fine. They did the same thing though. Same thing. Yay. Okay. Questions. I know that this was perhaps a heavy lesson. There was a lot to think about. There was a lot going on. But if you can understand the proofs that we went through, if you understood the reasoning, you are one step closer to being able to write your own proofs. So, applaud yourself for really trying to understand those proofs. And if you have questions, if you are needing help understanding any of those proofs, in order to get to the light bulb brain, you have to be the question brain first, and you have to ask your questions to get to the light bulb. So please, ask questions if you have them. Alright, and as usual, practice problems. Practice problems. From the book, are there... Nope, just one slide of practice problems. Do these if you'd like to practice the skills that you learned in this video, and I highly recommend trying these, but also make sure to do the homework that your teacher has assigned as well. As usual, let's end this video with a launch. This launch comes from Hazrat Inayat Khan. I feel like I butchered that name, but I apologize. Okay, so, they say, some people look for a beautiful place, others make a place beautiful. The difference, some look for a beautiful place, others make a place beautiful. So you can go through your whole life looking for the perfect house you want to buy, looking for the perfect key to happiness, the perfect, you can go through life looking for a lot of things, the perfect job, the perfect whatever. Others make a place beautiful. If you don't like your job, make your job better. If you don't like that it's boring, find a way to liven it up. And if you really can't, get a different job and make your work life beautiful. If you can't find the perfect house or the perfect apartment, make it perfect. Make it. If you don't like the yard and the flowers that are in there, rip them all up, change them. If you don't like the friends you have, go make new friends. You can sit around and you can whine about, oh, this place isn't beautiful, my situation isn't beautiful. Or you can take that situation and you can make it beautiful. You can make new friends. You can make your apartment decorated with whatever you want it to be. So, don't look for a beautiful place, make a beautiful place. That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.